Okay, so these are the subjects we'll be going through. They all regard linear graphs, so we'll be going through these 6. The most difficult would be perpendicular lines, or solving via equation. I hope this helps you, babe. Okay, so here we'll be discussing linear equations and the theory behind them. So of course we have our equation, y equals mx plus c, where m stands for the gradient, and c stands for your y-intercept. This is essentially where the line cuts the y-axis. Okay, so if we draw a line, that will be your y-intercept right there. And your gradient is essentially your rate of change. This means your change in y over your change in x, also known as rise over run. So if we put this into actual questions and working, we'll see how it works properly. Okay, so writing our equation again. Here our gradient is 3, and our y-intercept is also 3. For simplicity, we might actually scrap the idea that the y-intercept is 3 and change it to 0. So essentially what this means, a gradient of 3 is for every 1 across, it goes up 3. That's what your gradient stands for. So 1 across and up 3. There. Then we join those dots to make our line. We can try it in an actual question here, taken from an exam paper. There, so we've marked our gradient and our y-intercept. First, we start off by marking the y-intercept, because that's where we know where to start our line. So essentially, this means you're going 1 across and 3 up. So if the gradient was 5, you'd be going 1 across and 5 up. There we go, 1 across, 3 up, 1 across again, and 3 up again. And then we join up the points. For the other points, we can just use a ruler to find out where they are, because the line is straight, so they'll have to be along the same pattern as well. 1 across, 3 up. There we go. Here's another question where you're given a line, and you're instead asked to find your equation. Find the equation of the straight line. So first we find out our c, which is 1, essentially where it crosses the y-axis. And then we find our gradient, which is essentially the next clean cut like the line takes through the graph. So there's our next clean cut, so we can see it goes across by 2 and up by 4. Now if we factor in rise over run, or change in y over change in x, we can make the equation 4 over 2, because it's going up by 4 and across by 2. 4 over 2 is also equal to 2, so we know that our gradient is 2. And the equation of our line would be 2x plus 1. On the other hand, if the line was going from left to right, we would have a negative gradient. Okay, so let's move on to something more challenging, solving by equation. So what we have here is our starting equation with the gradient and the y-intercept. The gradient, remember, is rise over run, or change in y over change in x. So first we want to write down our coordinates that we're given. Okay, then we're going to mark down our y-coordinates first, and our x-coordinates. Remember, the x-coordinates come first, all the time. Okay, so now we're going to find the change in y, so 5 minus 2, over the change in x, 3 minus 9. This is equal to 3 over minus 6, which is equal to minus a half. So we know that our gradient is minus a half, plus, and then our equation of line will be plus c. So now we want to substitute one of the coordinates values into our equation to get c. There we go. And then we rearrange it to solve for what c is. It's not much more difficult than solving a regular equation. There we go. So c is 13 over 2. So the equation of our line will be minus a half x plus 13 over 2. There we go. Okay, so normally when solving equations like these, you can also sketch a rough graph, just so you can get a rough idea of how it's meant to look and what your equation is meant to turn out like. There we go. So actually this question is easier than the one we did before because you're already given the gradient. So we know that the gradient is 6, and all we need to do is take the coordinates we're given, sub them into our equation, and use them to find c. There we go. Not too difficult. Move the 18 over to the other side, and we get 1. c is equal to 1. And our equation is y equals 6x plus 1. Moving on, we have to tackle parallel lines. So parallel lines essentially have two characteristics. Same gradient, but a different y-intercept. Okay, so for example, we have a line y equals 5x plus 3. A parallel line to that would have y equals 5x again, plus any value of c. It could be 4, it could be 300. As long as the gradient stays the same, the line is parallel. Okay, so we can attempt a question now. It follows the same principles as the equations of a straight line. Okay, so find an equation to a line parallel to y equals 5x plus 3 that passes through 5, 5. So we know that our gradient stays the same, which means we already have the m, or the gradient. So all we need to do now is sub in the coordinates. So we sub in our y-coordinates and our x-coordinates, and then we try to find c from that. There we go, 5 minus 25, c is equal to minus 20. Pretty easy. So our equation is y equals 5x minus 20. Okay, so now we move on to the most challenging part of straight lines, perpendicular lines. Essentially what this means is basically what perpendicular lines are lines that intersect a line with a 90-degree angle. So that'll be our regular line. and the one intersecting will be perpendicular. So the gradient of our perpendicular line is what's known as the negative reciprocal. Okay, so to find the negative reciprocal, we have to make a fraction with our existing gradient, flip that fraction around, also known as the reciprocal, and then make that a negative just by adding a minus sign. So you can have a go at this one. Try and find the negative reciprocal of 5x. So yeah, first you write it as a fraction. Then you flip your fraction. And then you just add the negative sign. There, 5 over 1, 1 over 5, and negative 1 over 5. Now what if your gradient is a negative? So you do the same thing. Minus 3 becomes minus 3 over 1, which becomes 1 over minus 3, which then becomes negative 1 over minus 3, which is just equal to 1 over 3 because of the double negative. So here you go, babe. You can try this one for yourself. Okay, so here we go. Turn it into a fraction, flip the fraction, and turn that into a negative. Pretty easy. Okay, so now we have a very common exam question. So first we have to find the gradient by finding the negative reciprocal. So 4 over 1 becomes 1 over 4, which becomes negative 1 over 4. That's our negative reciprocal. So the perpendicular line gradient is negative 1 over 4. Now we actually don't need to look for C, because when the x-coordinate is 0, the y-coordinate is always the y-intercept. As such, we're already given the y-intercept, which is 6. However, in the case that you're not given the y-intercept, this will be how you do it. Okay? So we're given 1 point on the line, 3, 5. Actually, for simplicity, we can change that to 4 over 5. There, so we just substitute that into our equation, like we did for the other straight lines, and we use that to find C. So we can expand and move the minus 1 to the other side, and we get C is equal to 6. Perfect, so we can just rewrite that. There we go. That's how you solve for that equation. And that's how you solve for a perpendicular line. Okay, so we're almost done. There's just one more thing you want to remember. Is that you must always make y the subject of a line. Occasionally you'll be given equations like the one I've written down, where y is not the subject. You want to make sure that you always make y the subject. So you move over the x and with the 5, and then you want to make sure that it's y without a coefficient, so without the 2. So you'll just divide everything by that big number next to y. There we go. That's the equation you want. So that's pretty much it, babe. I really hope that helped. I love you, and I'll send some more videos and practice questions so you can ace your test. Bye.